Okay, I'm back with an update. Shortly after I released my last video, the group at MIT event released their software code for their design, and so it was nonsense for me to keep typing away on my own code, because if I wanted to incorporate any of the other features, it would have been pages. The source code is pages after pages after pages. It would have taken me months to type that up, and probably wouldn't have been at that high quality that they produced. Thank you guys for doing that at MIT. I've ported it over, keeping my hardware, and I'll explain the reason why I kept my hardware. Had to disable the pressure sensor because the pressure sensor that is required for their design is nowhere to be found. Surprise. I've opted to buy 4 different sensors, some of them amplified, some of them unamplified, and without temperature correction. So they have to be differential pressure sensors to measure the difference between ambient and what is actually at the patient's supply end, right close to the mask. And I'll get to that in detail later. So right now we have the setup as it is. This first 3 knobs are the same as I had it. Tidal volume, respiratory rate, which I had breaths per minute, IE, inspire-expire ratio, and this is what we added. That's what the MIT group had, was breathing assist, which I also was working on it, and they had it already incorporated, so that's why we went with that. It's basically the patient could initiate a breath if he wasn't, and he would actually dictate the respiratory rate. And if he would fall below the dial-in respiratory rate, the machine would actually do a respiratory cycle. And so that's, I think, a very valuable feature to have, which is very desirable. So we can actually fire it up. So I have it on. Let's just start out. So if I would change a setting, for example, I would go to 300 milliliters. I just would confirm it, would blink until it's confirmed. So if you accidentally would hit a knob, it would stick to the old value. Possibility of putting some different, other than analog to digital pod on there. I could think maybe like an optical encoder with the clicker built into the knob. But since my goal is to make it as inexpensive as possible and accessible to everybody around the world, would be still to stick with the pod. But we'll make multiple options at different pricing scales for people to build. And again, I would just provide the plans. You have to buy whatever electrical components, and of course it's all open source, so be free for anybody. Respiratory rate, same thing. If I'd increase it, I'd have to push confirm, and it would become immediately active. And let me see if I can get the picture of the mechanism. And IE ratio, it's at the 4. We'll go back to 1 to 1. It's in decimal increments. And pressure, of course, reads 0 because I do not have a pressure sensor built in. To adopt the software and actually do some test runs without a pressure sensor, I have to disable it in the source code, which is not very complicated. The mechanism, as it is my original mechanism that I designed on the 28th of 2 months ago. Yeah, well, a month and a half ago. People ask me, why do you stick to this design? It's very simple. I read in the morning, I built this. I read an article about the New York National Guard being trained on, let me disconnect this. This is just a data logging cable. Being trained on how to use a BVM bag because it looked like they were running out of ventilators. And that was enough encouragement to get me out in the garage and build this and post that video that afternoon. That was a purely mechanical ventilator. I think it was still better than a poor National Guardman squeezing a bag day on end, 24/7, 7 days a week, and probably more consistent as well. So, and here again, I can show you how the tile volume when I change it. How this just changed it to. So this is now 100 milliliter. Again, use an optical encoder to get the achieved position, and it's about as precise as can be. Well beyond the precision required for air delivery. As soon as we get the pressure sensor and the breathing assist, that would be a great feature. Because that way the patient actually can set the respiratory rate. I also milled out the circuit board for the, got rid of the spaghetti wire that I had in my original, when I posted the original video, this was just a breadboard in the design phase, the prototyping board. So I have now is the circuit board that you see there with the processor pushed on the back end, and with, again, minimal component, minimum complexity. It's very inexpensive. Yeah, my controller, it's the proprietary one, the same one that MIT uses. I don't want to endorse anybody's products. I'm a big open source guy, so I will work on a H-bridge design that everybody can build anywhere, and I'll make the circuit large enough that you can do regular photo edging and do it at home or wherever you are in the world. You should be able to accomplish this. And there's just the buck booster in the back as a power supply, and if I get the video turnaround. The front side of the board, you have an onboard voltage regulator just to give it a nice clean 5 volts and minimal noise, because I'm sure the pressure sensor is probably pretty sensitive. And it has an area for also data logging for an SD card. I'll have to install the sub board for that once it comes into the mail. And I can also just quickly go snap over to my PC. I just put a little thing. Okay, that's my board that I milled out here. Let me just give you a quick run through. So you see the microprocessor mounted on the back end of the board. And, whoopsie, that's the front side also. The processor actually mounts onto these header pins. It's just pushed on. And let me go click through here. Okay, that's the front side. The 4 connectors that you see here, that's for the pods are connected, and I actually took those off again. I just soldered the potentiometers on because just for durability and accuracy, if there was a shaky connection, a small resistance could change the value. So nothing beats an old-fashioned solder connection. And again, I milled this out with a 0.1 millimeter end mill, but this can be easily photo edged. As you can see, I had to do multiple passes. It's a 1 millimeter tray spacing, so easily done at home if you don't have CNC equipment. And only modification, this again was the same that MIT used, except I made a few changes. There you can see it's before I push the LCD, and the LCD just connects to the headers. Let's see if I have another. Now, doesn't show much, but you can see where the circuit board mounts, which now I of course have together. That's being milled out and drilled out. Yeah, that's all stuff it's boring. Okay, so we go back to zoom in again. And there we go. So as soon as I get the pressure sensor, I will post another video. The software right now as it is, it's fully functional for everything except the pressure sensing and a breathing assist because you need a pressure sensor. Working on the volume delivery, there was a gentleman that posted, was kind enough, I can't use his name because I didn't get his permission yet, but he's a physician and electrical engineer. He designed the volume meter. It's based on an impeller, a laser transmitter receiver, and you can tell velocity, and then you can actually calculate that volume. And it's should be easily to replicate with some level of minimal machining. And so I will build one of those for Inspire and the Expire side, and make a differential comparator for if there was a leak, you could detect it. That's what you don't even have in, interestingly enough, in the hospital grade ventilators, which is absolutely shocker to me. Not all of them have it, and it's not a requirement. But that way you could detect if there was a leak, proper volume actually factually delivered in a closed loop. So I think that would be a great feature. And I will post all this online. A little disclaimer, I'm not a physician, so for legal liability, if you're not a physician or in the fields that expertise of anesthetics or respiratory treatment, please do not use my device. I don't want to be liable for any harm. As again stated, I want to help people, not harm people. If you're a physician, please feel free to use any of my designs, download my plans, core software code. Thank the people at MIT for releasing the code. They did a fantastic job, great contribution to society, and I will post my modifications to the code. And I will, now that I have this all pretty much tested, it's been running for days, I'll get rid of all the scrap. I literally built this out because that's, like I said, I just cobbled this together out of junk from my machines, the metal parts. I'll get some new stock. We'll quickly machine all this stuff, stick it in a box that actually looks like industrial grade, manufactured, and publish the plans for anybody who wants to reproduce it, excuse me. And keep updating as we go along, but as it is right now, it's still better than a human being, I think, squeezing a bag, and more reliable and fully programmable. So thank you, everybody. I'll keep you guys posted, and the links are below on some of my other videos if you have any questions. Thank you.